Sometime within the next few years, the most powerful computers on Earth will run out of food. Since the launch of ChatGPT, tech giants have been strip mining the internet, consuming trillions of words written by humans to make their machines smarter. But the internet is finite, and we are about to hit a hard, invisible boundary. It is called the data wall, and when we hit it, the exponential growth of artificial intelligence could grind to a sudden, catastrophic halt. To understand why this is happening, you have to look at how we built the current AI boom. It was a strategy of pure, brute force scale. AI researchers discovered a simple rule. If you build a bigger neural network and feed it more data, it gets smarter. So, they fed it everything. They downloaded the Common Crawl, a massive digital archive of the entire public web. They scraped Wikipedia, millions of digitized books, Reddit threads, and YouTube transcripts. For 5 years, building better AI was simple. You just hooked a supercomputer up to a fire hose of human words. It did not matter if the data was messy or chaotic. The sheer volume was enough to teach machines how we think. But then, researchers at a think tank called Epic AI ran the math and discovered a terrifying trajectory. We are consuming human language far faster than we produce it. By some estimates, the supply of high-quality, publicly available human text will be completely exhausted as early as 2026. Think about what that means. Every book ever published, every blog post, every scientific paper, every public tweet since the dawn of the internet, used up. The giant has eaten the entire forest, and there are no new trees left to cut down. If developers want to make the next generation of models 10 times more powerful, they cannot simply download more web pages. There literally are not enough pages left on the planet. This creates a desperate temptation. If we run out of human words, why not just have AI write its own training data? It sounds perfect. Infinite, free, synthetic text. But that is where we run into a lethal mathematical phenomenon known as model collapse. Think of it like intensive farming. If you farm the same patch of topsoil over and over again, you strip away the nutrients. If you try to replenish that soil by grinding up the dead crops and dumping them back into the ground, the system degrades. In AI, when a model is trained on its own synthetic output, it starts to amplify its own subtle errors and biases. Within just a few generations, the output turns to gibberish. The grammar breaks, the facts dissolve, and the intelligence vanishes. This is the autophagus loop, a machine eating itself until it dies. We cannot automate our way out of a human data shortage. With the public web running dry, a desperate, multi-billion-dollar scramble has begun behind closed doors. Tech giants are no longer just scraping the web, they are buying it. Reddit signed a $60 million annual deal to license its user conversations. Stack Overflow partnered with OpenAI. News organizations are being offered millions for access to their archives. But even these vaults are finite. The real gold rush is not for static archives of the past, but for active human intelligence in the present. If you want high-quality data, you have to capture humans while they are actively solving complex problems. Tech companies are realizing that the most valuable data on Earth is not sitting on a public web page. It is trapped inside the brains of experts, scientists, engineers, and doctors at the exact moment they are doing their work. The popular narrative says that AI is on the verge of replacing human professionals entirely. But that is where everyone is wrong. In reality, to get to the next level of intelligence, AI needs humans more than ever. It does not need us to just passively write blog posts. It needs us as active collaboration partners. Recent research from late 24 and 25 reveals a massive pivot in machine learning. Instead of building isolated systems that spit out answers, developers are building mixed initiative frameworks. For example, in high-stakes fields like skin cancer diagnosis, researchers are using concept bottleneck models. Here, the AI does not just give a diagnosis. It collaboratively builds hypotheses with a human specialist. By watching how the human doctor refines, corrects, and challenges the machine, the system captures highly structured, verified data that simply does not exist anywhere else on the internet. This shift is transforming the entire software ecosystem. We are seeing a new wave of developer tools designed solely to capture this active human workflow. Tools like -X act as sidekicks inside your data workspace, recording every click, query, and adjustment a data analyst makes. Platforms like Finnick build automated agents that learn by navigating the web alongside humans, transforming real-time browser actions into training data. Even the underlying architecture of the internet is shifting. Projects like AIGR.ID are exploring decentralized, open infrastructures that allow everyday users to share and coordinate their diverse inputs without handing a monopoly to giant tech cartels. The era of the passive, scraped web is dead. The era of the active, agentic human AI loop has begun. For years, we feared a future where machines would outgrow their need for humanity. But the physics of data has revealed a different truth. The boundary of artificial intelligence is not compute, or algorithms, or electricity. It is us. The human experience is a non-renewable natural resource, and the web was just the low-hanging fruit. As we scale the data wall, the survival of artificial intelligence will not depend on how fast machines can think, but on how closely they can work alongside us. The machine is not going to replace the human mind. It is going to have to learn to share it.